Okay, yeah. So I'm recording now, and like I mentioned, you need to know how to name structures, but you also, on a test or final, will be expected to draw these structures by hand. And it's very easy. And we're going to look at this now today. So if I can get us through drawing these today and maybe introduce some common names, I think we'll be done for today. So very quick. Okay, so slide 39, writing molecular structures, or I should say, drawing molecular structures from the IUPAC name. To do this, you have to break the name down into its pieces, meaning look at the suffix. What family is the hydrocarbon? Now, in chapter 2, we're only doing alkanes. So the family for today is just alkanes. But later, the family might be alkenes, alkynes, it could be alcohols or aromatics. So you need to look at the family, the end of the name. Work backwards from there and look at the parent. So you know that the number of carbons, or sorry, the number of carbons present. Remember, the parent is actually your kind of Greek word like penta or hepta or oxa. So if I say octane, I don't know why I just said oxa, I mean octa. If I said octane, that's a family and parent together. And the family, ane, means it's an alkane. The oct is our parent, which means there's 8 carbons, all single bonded. Then step 3, the hard part, and none of this is hard, guys, is you identify any substituents, any branches on that carbon, and using your prefixes, using the number, put those substituents on that chain. And I mean, that's it. It's really simple. So guys, let me, and again, this is very hard because on like a D2L quiz, you can't do this. There's no software for D2L that I know of that lets you draw, nor do I want you to be drawing on D2L. But for the test or for a lab or for your final exam, you might need to do this. So let's break this down. The suffix tells me that this is an alkane. The parent tells me that it has 7 carbons. So, I mean, I'm halfway there. I'm going to draw 7 carbon chain in a straight line. Well, not a straight line, but a continuous chain, and only single bonds. So just from this alone, just from the word heptane, I know I can do 1, 2, 3, 4, 5, 6. I knew that was going to happen. 6, 7. So 1, 2, 3, 4, 5, 6, 7. Okay. Now, these are my substituents or my branches. And like, think about it, break it down. 2,2-dimethyl. That means on the second carbon, and you can number this left to right. Your molecule might look different than mine, and I'll explain that in a second. But I'm a left to right person. I guess it's because of English background, so we write right to left. If you guys wanted to go left to right, right to left, whatever, I don't care. But for me, I numbered it this way. So on the second carbon, I'm going to put 2 methyl groups. And remember, I don't go one up or one down. I do what kind of looks like rabbit ears, like that. Oops, sorry. There you go. That is 2,2-dimethyl heptane. And honestly, guys, if you number it differently and you went backwards with your numbers, and I mean, even saying the word backwards is wrong. I mean, there's no rule here for right or left. This is fine as well. Okay, so when I mark this on a test or final or a lab, I'm looking for both of these. Okay, so I gotta, this one, there's a problem with this one. Can I change and, give me 1 second, guys. I'm gonna mute my mic for 1 second. This one, there's a problem with the name, and it's because of the 1. Let me just change that number, and I'll be right Okay, actually, sorry. No, we are good. There's because it's cyclo, I think this is actually fine. If this propyl was on a straight chain, this wouldn't work. But look at this. This is a cyclohexane. So, okay, there is no problem here. I didn't read it fully. So let's break this down. And after this, I'm going to give you guys one or two to practice, okay? So let me do this one, and then I'll ask you guys to do a couple, and that'll be it for today. Okay, family, it's an alkane, all single bonds. Parent, cyclohexane, so this is 6 carbons in a ring. Now, for the rings, you guys should know how to draw cyclobutane, cyclopentane, and cyclohexane. Butane looks like this, pentane looks like a house, and hexane looks like this. And I drew that really quick, but I'll show you how to draw cyclohexane. Okay, so what I do to draw a hexane ring is I draw 2 carbon, and this really applies to benzene rings as well. I draw 2 lines parallel to each other, spaced apart. And then all you need to do is connect the tops with like a triangle, like you're making a house, like a roof of a house. So this right here is cyclohexane. And let me show you again. And that one was kind of ugly anyways. So 1, 2, oops. And then I just connect it with a little triangle here and a little triangle here. And there you go. Not the perfect, not the most perfect, but there is cyclohexane. Okay, on the first carbon, which you can pick any carbon you want, you need to draw a propyl group. Propyl is 3 carbons. So 1, 2, 3. So notice I'm calling this carbon 1, and then 2, 3, 4, 5, 6. And on the third carbon, a methyl group. And there you go. Okay, now this name itself isn't perfect. There is kind of a mistake here. Typically, you would put the M before the propyl. So if you were naming this in alphabetical order, you would say 3-methyl-1-propyl because M comes before P in the alphabet. So LMNOP. But not a big deal. If you guys did this on a test, I'm totally fine with it. So why don't I give you guys a couple to practice? I'll give you guys 2 to practice. And then we will, I have a really good question from Naim. I'll give you 2 to practice and then we'll pretty much finish for today. Now, Naim has a great question. He says, 4 carbons on the first group. So let's look at this. And I know exactly what you're talking about. Okay, so this carbon here is the first carbon on, or like the number 1 carbon in my ring. These carbons in the ring do not get counted in my chain or in my branch. Just like over on the left, this carbon doesn't get counted. So these are methyl groups. So this is, I'll pick another color. Let's pick green. 1, 2, 3 carbons. Okay, so I know what you mean about 4, but we start the branch away from the parent. So again, like over on this side, I don't count this carbon in the chain. I only count the carbons on the end. All right, does that make sense, Niam, or everybody? This takes practice, guys. I mean, this isn't the easiest thing in the world. Takes a little practice, and you can do my worksheets online for more practice. And if you run out of practice to do, there's so many more worksheets on Google. And Naim, ask your other question, no problem. And then I'll do 2 practice problems and you're done. All right, while he's typing his question, I'm gonna make a blank slide here. Oh, his question is ready, I think. Yeah, so the question in the chat, if people are following along, the chat is, oh, no, that wouldn't be okay. If the group was cyclopropyl, or if the group was cyclo, it would say cyclopropyl. So the question from Naim is, would it be okay to draw cyclopropane there instead of propane? And the answer is no. If it was cyclopropane, the name would say cyclopropyl. So this does not say cyclo, so you cannot draw a cyclo group or a circular group. All right, here we go. Let me give you 2 practice problems. And that'll be it for today. I'll put up the words. You guys try to draw them on your own if you have a pen and piece of paper, and then we'll do them together. So, okay, I gotta make these up so that they actually work. So let's do 3. I'll make it a little higher. Oops. So sorry, guys. My wrist hit the keyboard. Okay, so 3 ethyl, 2 methyl. Let's do hexane. Okay, so that's one of them. And then we will do, let's do, one, sorry, I'm just kind of making this up as I go. 1 ethyl, 2, no, let's change a different number. Let's go 3 methyl, cyclopentane. Sorry about that spelling there, guys. I hate my pen. I hate my pen so much. Oh my. Pentane. Sorry, I ran out of room there. So I would love for you guys to try these 2. They're not the most creative, but they kind of give you guys a chance to try some of these on your own. And I'll pause myself and mute myself, and I'll give you a couple minutes to try that. Naim has already done it in your head, which is perfect. If you have paper in front of you, you can try that. And I will be back in maybe 2 minutes. We will look at the answer, and halas, we are done. Okay, so I'll be back in 2 minutes. Okay, okay, guys. Sorry, you're all pretty quiet today, and that's pretty normal. It's pretty late on a Monday. It's almost 10 after 4. So let's get this finished, and then tomorrow, I think we have class tomorrow or no, Wednesday, whenever our class is next. I don't have my schedule in front of me. Let me see. On your next class, we'll go through the next section. Interesting. Oh, well, anyways, okay. So let's go through this. Let's look at these answers, and then next day.
So you want us to do it?
If somebody wants to take control and draw on the screen, absolutely. Why doesn't
we can do it?
Yeah, do it. Yeah, draw it for me right now.
Do you want me to do it?
Someone's drawing it right now. Anybody can draw.
Okay, I'll draw it.
Perfect. And I will see how you do. Take your time. Looking good so far. 1, 2, 3, 4, 5, 6. Perfect. So you have hexane. Keep going. There's your ethyl group. Perfect. Right? 2 carbons. And methyl. That's it. Perfect. 100%. Excellent. That is full marks. If you did that on a test, perfect. He has his ethyl group down here at the 3rd carbon. He has his methyl group there on the 2nd carbon. I mean, beautiful. Nothing wrong with that. Do you want to try the next one? Cyclopentane? Remember, yeah, why don't you try that one? Remember, cyclo pentane looks like a little house. I'm
Yeah,
not,
so I
okay.
know.
All right, let's see that one. And then that's it. I guess houses in Doha look different because the roofs are flat. This is like a European house or an American, North American house. So there you go. There's cyclopentane.
So I'm using my computer mouse, so
Oh yeah,
also
that's I've been
my
there.
laptop mouse.
Yeah, that's fine. When I was a kid, I used to use my mouse to draw in Microsoft Paint, and it's quite hard. Okay, so there's cyclopentane, beautiful. 3-methyl, perfect. And we just need that ethyl. One more line and you're good, sir.
Yeah. Yes. Okay.
I need one more line
Okay.
on, yeah, one more.
Yeah.
You're so close.
Yeah. I forgot about this one.
Ah, okay, hold
No, no,
up.
not this one. Not this one. Here, here. Okay. Sorry.
Okay,
Yes. Confused.
there you go. I fixed it. Perfect. And so everybody paying attention, this is perfect. He has the ethyl here. Ethyl. He has his methyl. And we have cyclopentane, 5 carbons. Beautiful. 10 out of 10, 100%. Um, that's it. That's it for today. So personally, and thank you very much for that. Personally, I think it's a little easier to draw them than it is to name them. With naming, you have to worry about the formatting, the numbers, the spelling. Drawing them is like really easy. Take it part by part. Start with the cyclopentane like that student just did. Put a methyl on the 3rd carbon, an ethyl on the 1st carbon, and you're done. The only substituents you guys really need to know are methyl, ethyl, and propyl. Anything longer than that, it just gets too crazy. So guys, that's it. Perfect. I'm going to hit stop record. If you have any questions, let me know. Please do not show up tomorrow for the lab. You guys can stay home and sleep in. And if you have any questions, send me an email. I will be available on email all day and night today and tomorrow. Okay, so have a great day, everybody.